My name is Lauren, and today I will be explaining how to do the unit circle and its radians. This is video part 2 of 3. First, I will explain the unit of angle measurements within the unit circle. We have degrees and radians within the unit circle. There are 360 total degrees within a unit circle and 2 pi total radians within a circle, meaning within a full rotation within a circle you have 360 degrees or 2 pi. As you can see, the degrees are already filled in within the unit circle, which was done in video part 1. In this video, we will be explaining how to fill in the radians within a unit circle. Let's get started. We know within a unit circle that there are a total of 2 pi as seen in the definition over here. So we can write 0/2 pi, as this horizontal x-axis right here could be 0, or it could be a full rotation, meaning it is 2 pi. We know that half of 2 pi would just be pi. So 180 degrees would also be known as pi. We can also see that 2 pi over 4, or a quarter of 2 pi, would be pi over 2, meaning 90 degrees is pi over 2. Next, you can see that this 270 degree angle covers a total of 3 sections. Right here, 90 degrees, 180, and then 270, meaning we have 3 pi over 2. So 270 degrees is equal to 3 pi over 2. Now we can move on to the 45 degrees. In order to find the 45 degree angle right here, we're going to have to take pi over 2 divided by 2. Or, in other words, pi over 2 times 1/2, as you can flip the 2 to be its reciprocal and multiply by the pi over 2, which therefore equals pi over 4, meaning the 45 degree angle is equal to pi over 4. Next, we can do all the corresponding pi over 4 radian degree angles. All of these lines in red are the corresponding pi over 4 angles. As we increase by intervals of pi over 4, you can see that we now have 3 pi over 4, 5 pi over 4, and 7 pi over 4, which are all corresponding angles to pi over 4. We get these angles in radians by adding pi over 4 to itself to all the corresponding angles. For instance, in order to get 3 pi over 4, you would do pi over 4 times 3 over 1, which would therefore give you 3 pi over 4. Next, we will move on to the 60 degree corresponding angles. As you can see, 60 degrees would be pi over 3, as 1/3 is less than 1 over 2, or 1/2. This also makes sense because 1/6, which is equal to 30 degrees, is less than 1/3, and 1/6 times 2 over 1 is equal to 2 over 6, or in other words, 1/3, which returns you back to this. All of these red lines are the corresponding pi over 3 angles. As you can see, we now have 2 pi over 3, 4 pi over 3, and 5 pi over 3 filled in. We got these angles by using pi over 3 as a reference angle in order to get the corresponding pi over 3 angles. Next, going back to the pi over 6, we can see pi over 6 is equal to the 30 degrees, due to the 30 degrees increasing upon itself in order to get to 60, 90, 120, 150, and so on degrees. With that being said, we know that pi over 6 times 2 over 1, or 2, is equal to 2 pi over 6, which is therefore equal to pi over 3, which gives us the 60 degrees right here. Now that we know pi over 6 is equal to 30 degrees, we can fill in the corresponding angles for pi over 6. As you can see here, all the red lines are the corresponding pi over 6 angles. The new radians we have are 5 pi over 6, 7 pi over 6, and 11 pi over 6. The other corresponding pi over 6 angles were already filled in by other reference angles due to the fact that the radians were able to be simplified down to a smaller number. That is how you find the radians within a unit circle. Stay tuned for part 3 of the unit circle, finding coordinates.